About number 11. So in question 11, we have a conical paper drinking cup, so a cone. Of course, if you're drinking out of it, it's going to be upside down. And they tell us the height is 6 inches and the radius is 2 inches at the top. So when this is 6, this is 2. And I'm going to come back to that in just a second, because chances are the only thing that I think there's a good chance the only thing that you got hung up on was something about how these two relate. Okay, but you don't know that at this point in the question anyway. So how fast is the water level in the cup rising? So how is H prime changing if water is poured at a rate of 1 cubic inch per second? So that's increasing the volume when you're adding water, and at the instant when H is 2 inches. Okay, so right here, one thing about a cone that you may not be aware about like this, but this to this is always going to be proportional. So when this is 6 and this is 2, this is telling me the relationship between R and H. H is the same thing as R if you multiply it by 3. So as that water level goes down, it's not at the top. This becomes less than 2, but so does this. This becomes less than 6. But it stays proportional because of Pythagorean theorem, honestly. Because as this changes, but this squared plus this squared has to equal this squared. So this is kind of the key to unlock this question. Now again, you probably don't even realize that you need that yet. So what you probably should have done is said, well, the volume of a cone is 1/3 pi r squared h, and you can take the derivative of that with respect to time. But here becomes the problem. To take the derivative of r squared h, now sometimes you need to do this, and sometimes they give you enough information to do this, but in this case, this problem, that was not true. R squared h, you have to do product rule here. And when you do that, you realize that there's something in here that you just don't have enough information to solve for. Never did they tell you how the rate of the radius is changing, nor do I think you have any easy paths to figure that out. So that tells me I don't want an r prime, which means the step before, I don't want any r's. So I want to think of, is there any way I could say the volume of a cone question, but instead of putting r's in there, let me only put h's in there. So then that's when you might think about this relationship, and instead of saying r, I could say h over 3. So for this particular cone, based on this ratio, this is the same thing as 1/9 pi h squared. 1/9 pi h squared. So now I could take the derivative, and when I take the derivative of this, there's no r's, so there's no r primes, so I don't have the same problem that I had up here. Again, you typically don't know that you have that issue until you're almost done and you realize that there's something you can't find. And I do think that that's the way to approach it anyway. So now when I do power rule, 1/9 pi is just a number, so I could just do power rule. Don't forget the h prime. Plug in 1 for b prime. Plug in 2 for h, and then solve for h prime. So in my calculator, I'm asking my calculator what is 1 divided by 2/9 pi, not that, divided by another 2, and that gives me 0.716. which leads you to this one. Should be your last question, because I think there's only 12 on here. Now again, when you see this question, don't worry about this in the top left. Don't worry about how H compares to R. That's kind of a last resort. Just start with the normal volume formula, take the derivative, remember product rule, remember all the primes every time you take a derivative. And when you have all of this stuff and you start thinking about what to plug in, you're either going to have enough to finish the question, that's best case scenario. You might be missing a thing or two that you could find, which would be the second best option, or you just realize there's something that you're never going to find, like R prime. So maybe there was something in the question that helped give you a hint. So this right here, that when the height is 6, the radius is 2, that's where I got that statement. So, but that only is true with cones, like how R and H relate to each other that way. Okay, was anybody else going to ask about 11? Need me to try to interpret any of this mess that's left up here?